This is a video for decision statements, conditions, and logical operators in C. First off, let's start off with the definition of what a decision statement is. A decision statement is a command that executes a block of code if one or more conditions evaluate to true. There are two types of decision statements in C, the if and the switch statement. The if decision statement syntax is if, and then in parentheses an expression, followed by an open curly bracket with the if body and the closing curly bracket. The if body represents the block of code that will be executed if the expression evaluates to true. Of course, you can have an else statement. So in this case, if the expression evaluates to true, it will execute the code in the if body, and if that expression evaluates to false for whatever reason, it will do the else section of the if-else statement and execute all the code in the else body. Of course, you can also have else ifs if you want. So it will test the first expression, and if that is false, it will go to the next one in the block, and it will try evaluating the first expression for the first else if. Now, if that's true, it will execute that code in the else if block and stop with the evaluating the rest of the if statement. If that expression evaluates to false, it will test the next one down the line, and it will keep doing that until it either finds one that evaluates to true or it hits the end of the if-else-if statement chain. And you can combine one or more of those with an else statement. So you can have if and then as many else's as you want, and finally wrap it up with an else. So if none of the conditions above or none of the expressions above evaluate to true, then it will execute the commands in the else body. Now, you don't need to use curly brackets if there's only one command in the if body. However, for consistency, you should always use brackets because it helps with readability. Also, always place the opening and closing brackets on a line by themselves. It should look like this. So you can see that the opening curly bracket is on a line by itself and the closing bracket is on a line by itself. Oftentimes in the book on the internet, you see them move the opening curly bracket to the end of the if line. Now, if you put it on the next line by itself, you can easily tell where the if body starts and ends. So, in the second example, it's mucius hardius terredius. Now, that's Latin for very hard to read. Indentation. You want to indent all the commands in the if body one more tab than the surrounding curly brackets. So for example, here we can see that the commands are not indented. Here we can see that they are indented one tab, so all the commands are indented correctly. And here it's indented one tab too many. This is called a double indentation. You have two tabs, so you want just the one in the middle. Why? Readability, of course. The expressions inside of an if statement is composed of one or more conditions. A condition has a left operand, a conditional operator, and a right operand. So here you can see the syntax. We got some value or variable on the left and some value or variable on the right, and in the middle we have a conditional operator. Now an operator or an operand, it can be a hard-coded value, for example 5. It can be another variable, int value. It could be a constant, for example SNG pi, or it could be a function that returns a value. Now the 6 conditional operators which you get to memorize are less than, greater than, less than or equal to, greater than or equal to, not equal, and equality. Now notice equality is a double equal sign. Some of you are accidentally going to put in a single equal sign, which is assignment, and that is going to cause much pain and suffering. Don't do that. Remember, conditional operator for equality is equal equal. Normally an expression compares a value in a variable to another value or another variable. So for example, if S&G price is less than 0, then printf the price can't be negative. Yeah, I've never seen anything with a negative price. That would be interesting if there was. Or you can compare two variables. So it says if int value 1 is greater than int value 2, then the larger value equals int value 1, else we know that value 2 must be greater than or equal to, and therefore the larger value is equal to int value 2, and it's in an if statement. So when we're done with this if block, large value will be equal to one of those two values. You can link multiple conditions together using a logical operator. The two logical operators you will use the most are and or. The symbol for the or operator is right above the enter key on most keyboards. Take a look at your keyboard and look for the enter key. Now the key immediately above that is the backslash key. Now if you notice on top of that backslash key is a vertical bar. That is what's called the pipe symbol. Now to get that, you press the shift key and the backslash key, and you should get a vertical pipe to display it. So test that out by calling up Microsoft Notepad or MS Word. So go ahead and pause, bring up Notepad, and type that in. So I'll do a little example right here. So here's Notepad, and I'm bringing in Viewport, and I hold Shift and type it in. There's my vertical bar, and there's a whole bunch of vertical bars. The vertical pipe symbol is supposed to have a gap in the middle so that it looks like two dashes turned or rotated 90 degrees. So the syntax for linking conditions together inside an expression is condition, a logical operator, either and or, followed by another condition. For example, I declare a user value integer variable, then I tell the user what I want. I want a number from 1 to 100, and then I have a scanf statement. Notice the ampersand, and notice that the placeholder in our format string matches the prefix. So int prefix tells us it's an integer. And here we check, we say if the user value entered is less than 1 or greater than 100. So there's our logical operator right there. So if either one of these conditions evaluate to true, then we print out an error message for the user. You should always have two sides with a conditional operator for every condition. I see students that sometimes do this, if BLN result, and then print it worked. If the Boolean variable BLN result contains the value true, which is 1, the condition will evaluate to true, and therefore the expression will evaluate to true as well. That's taking shortcuts, and I call that fancy coding. Don't do that. Do this instead. If BLN result equals, there's our equality, equals true, print it worked. Notice the equality operator is used, not the assignment operator. Now, why do we want to do this? I want to break the habit right here now of what I call fancy code. If you write fancy code, you will have fancy bugs, and when you get to 10, 20, 30,000 lines of code, that will be a nightmare. We want to keep our code simple so that it's easy to debug and maintain, and we are successful in the business environment, and our customers like the products that we create. Most people would say that's a good thing. In this example, we have the assignment operator instead of the equality operator. Now what that's going to do is it's going to assign the value of true to BLN result, and then it will evaluate the BLN result. Well, BLN result is true, so this if statement will be executed every time. It will always be true. That's not good. Now, I'd like you to all volunteer to do that at least once and waste half an hour to 45 minutes pulling your hair out, grinding your teeth, biting your fingernails, and then realize that you have the assignment operator, and yeah, so don't do that. Now, do you have to supply both sides to a condition? For this class, yes. Often co-op coordinators will ask my technical opinion of a potential hire. Sometimes company asks me to recommend people, and sometimes co-op companies specifically ask for a reference from me. Now why? Because I break students into good habits, coding habits, and I try to break them of bad coding habits. And the companies that use our employees have picked up on that. A lot of times some of the interview questions is, have you ever had a class from Pat Callahan? And then they ask, What'd you think of his class? That's a loaded question, so be careful. By the way, you're allowed to say it was a really hard class and had a really difficult time. So that's quite all right. Now, managers are concerned about the long-term ability to maintain a project. They want coders that write code that's easy to read. That's part of what you're learning to do in this course. And over 10 years of teaching with lots of feedback from students and employers has proven that what I'm teaching here is a good thing. Use at most 2 or 3 conditions in any single expression. If you have more than that, you want to break them up by dividing them into multiple and possibly nested if statements. For example, let's look at this. We have 1 condition, 2 conditions, 3 conditions linked together with logical ands, logical operator and. That gets hard to read. So it would be much easier written if it was like this. We have our first condition, and if the value is less than 0, and we can comment that, is it negative? Then we can say, yes, it is a multiple, and then we can ask, is it a multiple of 3? So if we modulus divide by 3, and we get a result of 0, the remainder is 0, then we know it's a multiple of 3. Then we can have a third nested if statement, and we can say, is it not a multiple of 5? So if we modulus divide by 5, and we do not get a remainder of 0, then we know it's not a multiple of 5, and then we can do something. So I recommend you use nested if statements instead of one long if statement. Avoid the use of the logical not operator because it's easy to miss. I often see this example in books or in forums on the internet. See that little exclamation point right there? So if not Boolean result. So if Boolean's true, if not that, do something. So if Boolean result is false, go ahead and do it. That's one of the reasons I get beat up if I go walking alone in C-Town. A lot of C programmers love this. Managers and senior programmers, at least most of the ones I train, don't. Now I recommend, and for this class require, that you do something like this instead. You say if Boolean result equals false. Notice you have both sides of the condition with a logical operator in between. Why? Readability. The other type of decision statement in C is called the switch statement. And the syntax for that is switch and then an integer expression or value. And then you have cases where you compare a value to what's in the variable. And if it matches, you have a colon, and then you have one or more statements followed by a break. And then you do that for as many values as you want. And then if you need, you can have a default at the end, and if it doesn't match any of your cases, you can go ahead and execute the statements in the default block. Notice the beginning and ending curly brackets. Notice that the code is indented inside those curly brackets, and notice that the statements are lined up and the breaks are indented as well. An actual example is a little easier to read. So let's declare a variable user menu choice, and we enter A for breakfast, B for lunch, C for dinner. I would have put those on separate lines, but I'm hurting on space in the window I've got here. So for purpose of example, I put them all in one line. Then I go ahead and I read a character from the user. So %C is a placeholder for a character, and notice we have the ampersand right there. That's we need that for all variables except for arrays and strings. We'll find out about that week 6-ish. Then we have our switch statement, and we put our variable in there, and we compare that with A, B, and C. And if we do find a match, then we're going to do breakfast. Now, a peculiar thing about switch statements: if it gets a condition that matches, so if a case matches, it will execute all the commands starting in that case, and will continue to execute all the commands all the way down until it hits a break statement. So if I don't have this break here, it's going to do lunch, and if I don't have that break there, it's going to do dinner. So after each case, I need a break statement. Here you'll see a common reason for doing that. If we read a letter from the user, it may be either uppercase or lowercase. So here, if the user menu choice is either a lowercase a, it will start executing that code in that case. There's nothing in there, so it will fall through and start doing the instructions in the uppercase a condition. and then it will break. And so what this means is it will do breakfast whether you enter an upper or lowercase a, it'll do a b, it'll do lunch if you enter an uppercase or lowercase b, and the same for dinner with a c. And by default, if you don't enter an a, b, or c, it will print out invalid choice. I think it would make more sense to make the user menu choice variable uppercase or lowercase so there are less comparisons that have to be done. So for example, there is a built-in function called toUppercase, and what that'll do is that will convert a menu choice variable, whatever the user enters, to uppercase, and then you assign it back to the variable, and then you just have to check A, B, or C, which means much cleaner code. Now by the way, this toUpper, you are not allowed to use that. If you want that, you're going to have to write it yourself, and we're going to learn how to do that very shortly. That's going to be one of the problems you're going to have to do. You can't use any built-in functions for strings or characters until I give you explicit permission. And that announcement will be, you won't miss it. It'll be something like, now you can all use the built-in string and character functions, and that will be probably about week 13 or 14 of the term. So until then, you can't use them. Why? It's boot camp. So what's the difference between an if statement and a switch statement? You can evaluate multiple conditions with an if statement, and they can be non-integer expressions. With a switch statement, you can evaluate only a single integer expression. Now the character data type, which we used in the previous example, let me scroll up. You see we're using a character data type right there, not an integer. We're allowed to do that because it is integer compatible, since it stores values from 0 to 255. Don't use hard-coded ASCII values in decision statements if you can avoid it. I often see students do something like this. If char letter is less than 65 or char letter is greater than 90, print invalid input. Now I guarantee if I took a poll of all the students in this class and I asked them to all raise their hands who understood what that meant, out of about 20 I'd probably have 3 or 4. Now if you're one of those 3 or 4 that knows what those ASCII values are, good for you. The problem is your coworkers, the people you work with, don't. And we plus it's all about good habits, and we want good habits, not bad habits. Now looking at that code, we have no idea what it's doing unless we've memorized some of the ASCII values in the ASCII chart. That code is definitely harder to read than it needs to be. But if we use the actual ASCII characters wrapped inside of single quotes, we can increase the readability substantially. So here we're saying if the letter is less than A or the letter is greater than Z, then we have invalid input. Now it's obvious to see that the programmer wanted a letter from the user from A to Z. Now if you are unfamiliar with what the ASCII chart is, the ASCII stands for the American Standard something Information Exchange. Anyways, let's go look up the ASCII chart on the internet, since you are going to need to learn how to use this. So I go to one of my favorite search engines and I type in ASCII chart, and I go ahead and search, and that brings me these search results, and then I'm going to go look at an ASCII table. Now what the guys did, American Standard Code for Information Exchange, that's what it means right there. What they did when they first started coming out with computers is they needed a way to make all keyboards the same. So you didn't want one vendor making a keyboard one way and somebody else making another. So what they did is they gave every key on the keyboard a number. And if we look, they print them out in different formats, but this column here is the decimal format. And so you've got 0 to 31, keys 32 to 63, keys 64 to 95, and keys 96 to 127. If we look up key 65, we can see that as an uppercase B. Is an uppercase A. 66 is an uppercase B, C, and so on. So when we asked if the letter was, let me scooch this down just a little bit, go back to our example. If we asked if it was less than A, then we're saying, was it any one of these characters down here? Alright, so we didn't want one of those. And then we asked if it was greater than C. Let me put that back up in the viewport. We asked if it was any of these up here. So we wanted just those that are in the range. Now by the way, uppercase letters are 97 to 122. But you don't have to memorize those, because you can always just use the characters by putting them in quotes for either comparison or assignment. Treat conditional operators, logical operators, and values like words. Put spaces before and after them to help with the readability. Compare these two if statements. On the top, I took all the spaces out, and on the bottom, I put spaces in and around the variables, the conditional operators, the values, the logical operators. And you can see it's much easier on the eyes. And when you're staring at that kind of stuff, 8 hours a day, 5 days a week, believe it or not, it really adds up. Now, one of the things I like to say is that you should be able to read through the code at 60 miles an hour. You guys all know what it's like when you're going down the highway and there's some huge potholes or traffic jam or whatever. It slows you down. You should be able to read through your code at 60 miles an hour, and that's for readability so that it's easier to maintain and debug and whatever. So that's why that the spacing and the formatting and the naming and all that is extremely important. Another thing is you want to make the condition match the assignment. All too often I see programmers write code that's harder to read than it needs to be. For example, don't do this. So here in the condition we ask if int value is greater than maximum value. And if it is, they assign maximum value to equal the value. Notice they switched the sides. Instead, you want to do this. You want to make your condition, if the maximum value is less than int value, then make maximum value equal int value. That way you don't have to mentally flip things around in order to compare the code and see what's going on. So what's that guideline? Make the condition match the assignment. Everyone say that with me. Okay. Make the condition match the assignment. Hey, some of you weren't talking. I need you to hear it. We're going to do it one more time. All right. Make the condition match the assignment. Good. You probably already knew about decision statements before this video, and at this point you may be thinking this material is easy. You may be thinking you're going to crush the homework assignments. Many programmers do well early on because the introductory classes teach what the parts are. This is a variable, this is an if statement, this is a procedure, and so on. It's pretty easy to learn the parts, at least for some people. Now, by the way, just to let you know, in college, programming was never a challenge for me. My Achilles heel was calculus and art. I can't draw to save my life. I'm not trained in that, but I had really bad study habits. Actually, I had no study habits when it came to calculus, and I got crushed. However, there comes a point when you learn all the parts, and then you have to start putting the parts together in order to solve problems. For example, there's a pile of parts, build me a bicycle. Then it gets more advanced. There's a pile of parts, build me a motorcycle. It has an engine. Then still more advanced. There's a pile of parts, build me an automobile. Many students fall down during this transition from learning the parts to putting them together. This happens usually about halfway through VB2. Why? Because the students are very good at learning parts. It's easy for them, and they try to use their old part learning study habits, which are practically non-existent, and their attitude of this is easy, I can just start at 5-10 minutes before class and I'll be done in no time, and they try to take those habits and attitudes to solve the problems. I'm here to tell you that won't work for much longer. Starting in about week 3, I'm going to give you a series of assignments that are going to require you to put the individual parts together to solve some pretty tough problems. Right now is just the lull before the storm. I'm not trying to scare you, well, maybe a little if you have bad study habits. I'm trying to prepare you for what's coming. Those of you who had my material for Sequel 1 have some idea of what's going to be involved. I'm not doing any of this to be mean. I'm doing it to prepare you for the business world. The worst possible thing I could do to you would be to give you really easy material and then turn this class into a joke. For example, Scantron tests, I could have you write essays about coding instead of actually do the coding, and I could give just a handful of assignments that wouldn't be very challenging. So, start mentally preparing yourself for some tough homeworks. You're going to miss a lot of TV, video games, or whatever. And that's the end of this video.